conic sections. So I'm giving you time. This is a parabola. It's asking you to find the vertex. This is the equation of a circle, and we want to find the center and radius of the circle. So a couple more minutes. Okay, I think we're gonna get started on these problems now. So the first one, we want to find the vertex of this equation that of the parabola y equals 2x squared minus 8x plus 8. Now, just as a reminder, we can tell we are now talking about what are called the conic sections, and the conic sections are the graphs of quadratic equations. They're the graphs that we get when we either have an x squared or a y squared or both in the equation. And the first type of conic section that we looked at was something called a parabola. And we could recognize that this is a parabola because it does have an x squared, but there's no y squared. The y is, the highest exponent on the y is just 1. It's just a plain y. It's called, the y is linear, but the x is quadratic. The x has an exponent of 2, the y does not. That makes it a parabola, which, if you recall, was a U shape. And the tip of the U, the place where the U turns around, is called the vertex. And the way we find the vertex, and that's what this question is asking us for, is to do x equals negative b over 2a. Now, the equation has to be in what we call standard order, where it's the y is equal to, and then the number in front of the x squared is the a. So in this case, the a is 2. The number in front of the plain x term is the b. That's a negative 8. Don't forget to include the negative with it. And the c is the standalone number, the constant, which in this case is positive 5. So if we want to find the vertex of the parabola, we're going to do x equals negative 8, because our b is negative 8, over 2 times 2, which gives us a negative. A negative gives us a positive, and a 2 times 2 gives us a 4. And the x value of my parabola, of the vertex of my parabola, is 2. Now, don't say the vertex is 2. A vertex is a point. It needs both an x and a y. So now, to find the y value, take this x value and stick it into your equation. So we're replacing the x with 2, so we get 2 times 2 squared minus 8 times 2 plus 5. And 2 times 2 squared is 4 times 2. This is 8 minus 16 plus 5. And if you add 8 and negative 16 is negative 8. Negative 8 and 5 is negative 3. So this comes out to be -3. So the vertex of our parabola is the point 2, -3. The general type of questions they ask you about parabolas is either to find the vertex or to find the x-intercepts, and that you do by setting the y equal to 0. If you want the x-intercepts, you set the x in. If you want the y-intercept, you set the x-intercept equal to 0. You want the x-intercept, you let the y equal to 0. The other thing is they might give you a picture, several pictures, and ask you to determine which is the correct picture. So the first thing you're going to want to do is locate the vertex. There are not going to be too many that are going to be at the point, have a vertex at 2, -3. The other thing you're going to want to look at very carefully is the A, because the A is going to tell you if your parabola opens up or down. When the A is positive, you have an opening up parabola. The A is negative, you have a opening down parabola. So we have a parabola. If we were looking for something, if we were looking at what the graph would look like, it would look approximately like this. Here's 2, -3 is right here. Here's our vertex, and we'd have to locate that, and then it's opening up. So that probably goes more, it's probably more like this. Let's get here. Something like that is what you would look for. Again, you'd look for the proper vertex and the direction opening up. It's unlikely that they would have more than one with the right vertex. So that's, again, how you would pick out that example. And I see Awa also gave us not only the, he gave us the points, not only the vertex, he actually figured out what the intercepts are. Thank you. Okay, so now let's look at the second question, which has to do with a circle. And we recognize the equation as the equation of a circle because it has an x squared and a y squared. Notice how it's different from the parabola that only has an x squared but no y squared in its equation. And the way we said we're going to find the center and radius of the circle is to put it in what's called standard format. We're going to put all the x's together. So we have an x squared and a -10x. And then we leave a space. And then we put the y's together. So we have a y squared and a 4y. And we leave a space. And any other number that doesn't have an x or a y, in other words, any constant number, we bring to the other side of the equation. So that's our first step, to put this in what's called standard format. Okay, the next thing we have to do is we have to complete the square on two things. We have to complete the square on the x's, and we have to complete the square on the y's. In order to complete the square, what we do is we take the number that's in front of the x term. The x squared term coefficient has to be 1, but the x, unless there's no x there, then that means that the x center is at 0. If we take the number that's in front of the x and divide it by 2, so that gives us -5. and we square that number. We multiply that number by itself. -5 times -5 is 25. And we put it in this blank space. We add it to complete, take these two terms. Now we have a trinomial that is a perfect square. That's why it's called completing the square. Of course, whatever we add to the left side, we've got to do the same thing to the right side. So I'm going to add 25 over here. This has then become x minus 5 squared. Now we're going to do the same thing with the y's. We take the number in front of the y and divide it by 2. That gives me 2. And we multiply it by itself. 2 times 2 is 4. That, of course, now gives us that this is y plus 2 squared. Put a plus in between these. And of course, I have to add 4 to the other side. So this side is complete. Let's just add up what we have on the other side. 7 and 25 is 32. 32 plus 4 is 36. And now this equation is in the standard form of a circle. And we can see that the center of the circle is +5, -2, because you always use the opposite signs. And the radius of the circle is the square root of this number, which is 6. So now, if we wanted to, we could draw that circle. Again, this is in the regular format, the expanded format. This is what's called the standard format of the circle, which tells where we can easily tell the center and the radius. Okay, so that took care of what we had covered on conic sections through Thursday. So we're going to now go on with our conic sections. We're going to finish the topic of conic sections by looking at 2 other types of graphs. As I said, there are a total of 4 different kinds of conic sections. The other 2 that we have to talk about is, well, we have, this is number 3, will be something called an ellipse. And the third thing is going to be something called a hyperbola. And just notice the parabola didn't have a place that you call a center. It had a vertex, it didn't have a center. But the circle certainly had a center. It turns out that these will also these 2 types of figures also have centers. Let's deal with them separately. Let's first talk about the hyperbola. Now we're going to, the ellipse. Now, just like this circle, we started out with having a circle where the center was at the origin. We're going to talk about both the ellipse and the hyperbola being centered at the origin, because we don't go into it any more deeply than that. We will not cover any types of ellipses or hyperbolas that are not centered at the origin. There, of course, when you get into higher level courses, you may come across these type of situations. So we're going to be talking about for the simplest type of ellipses and the simplest type of hyperbolas. So first of all, let's talk about the ellipse. I'm sure you've heard the term elliptical or an elliptical orbit or whatever. An ellipse is basically an oval shape. It's sometimes oval where it's slanted sideways, or sometimes it's oval vertically, but this is the shape of an ellipse. An ellipse is basically an oval shape. And of course, an ellipse, like a circle, will have a center. Basically, what an ellipse is a flattened out circle. Actually, the Earth is not a perfect circle or sphere. It actually is a little bit flattened out. It's really an ellipse in shape because it's flattened out at the north and south poles. So, and of course, if you look at the orbits of these planets around the sun, they're not total circles, they are what we call ellipses. They are elliptical orbits because they are not exact circles, they're longer and wider than a regular circle. So let's talk about the basic or the standard equation for an ellipse. The standard equation of an ellipse will look like this: x squared over a squared plus y squared over b squared equals 1. Now, what you're going to recognize, first of all, is that you have an a squared and an x squared and a y squared in the equation. So how does it look different than this equation of a circle? That also had an x squared and a y squared. It has both x squared and y squared. Well, because there's going to be either a coefficient in front of the x squared or over the x squared. The two numbers, the a and the b, are going to be different numbers. So what do we do? How do we graph an ellipse? What should we do with an ellipse? So let's first look at an ellipse that in its standard form. Suppose I gave you x squared over 25 plus y squared over 9 equaling 1. We'll recognize this as an ellipse because we have an x squared over a number plus a y squared over a number equaling 1. This is the standard format. Now, the number in this case, the a squared, is 25. That means my a would be either plus or minus 5. What the a gives us are the x-intercepts. There are two x-intercepts, one at 5 and one at -5. The b squared is the number underneath the y squared, that's 9, which means my b is either positive or -3. The b are the y-intercepts. So if I went to graph this, remember, I'm telling you my ellipse is centered at the origin. The only ones we're dealing with are those that are centered at the origin. What do? I go to my x-intercepts. So here's 1, 2, 3, 4, 5. and -1, -2, -3, -4, -5. That gives us 2 points on this ellipse. Then we go to the y-intercepts. Up 3, up to +3, down to -3. And with these 4 points, we can draw our ellipse. Just connect them, don't make them straight lines, just make an oval shape going through those 4 points. So once you have your equation in standard format, it's easy to figure out the x-intercepts and the y-intercepts, and then you can draw your ellipse. There are 2 lines that cut the ellipse in half. One is along the x-axis that cuts in half, and one is along the y-axis. Those 2 lines are called the axes of the ellipse. There are 2 axes. There's a horizontal axis and there's a vertical axis. One is longer than the other, because if they're both the same size, then what we have is not an ellipse, but we have is a circle. The longer ellipse is called the major axis. The longer axis is the major axis. In this case, let me write. In our case, the major axis is the one that's along the x-axis. It happens to be the horizontal axis. If I asked you how long is the major axis, well, it's going from -5 to 5, so the total length of the major axis is 10. Remember, the 5, the intercepts are from the middle, from the center to the edge, but the axis goes from one edge to the other, so it's double whatever the intercepts are. The smaller axis is called the minor axis. In this case, it's the one along the y-axis. In other words, it's the vertical axis in this case. And the length of the minor axis is from, well, it's going from -3 to 3, which is a total of 6. Basically, those are the different bits of information that you need to know about an ellipse. Again, an ellipse is a flattened out circle. Sometimes it's flattened horizontally, sometimes it's flattened vertically. You should be able to go from a picture of the ellipse to the equation, and from the equation to the graph. Okay, so we've discussed what happens when we have our equation in standard format. What happens if our equation is not in standard format? Let's look at that. Suppose I were to give you this equation. Let me just put this on the board. So keep this. This is the standard form. Suppose I were to have given you this example. 4x squared plus 25y squared equals 100. And I was told, I want you to find the intercepts. I want you to graph this, graph this thing. Now again, let's start from the beginning as if we know nothing. First of all, I see both an x squared and a y squared in my equation. It's obviously a quadratic equation. It's definitely not a parabola because it has both x squareds and y squareds. It'll turn out both this, all three, the circle, the ellipse, and the hyperbola, have both x squareds and y squareds. So how do we recognize that this is not a circle? That's because there are numbers in front of the x squared and the y squared. Either there's numbers, coefficients right next to it, or there are numbers in the denominator. In other words, if you had an x squared over a squared, your coefficient is 1 over a squared. The x squared is not a number, not standing all by itself. It has a number attached to it, either in front of it or under it. That is your clue that you have an ellipse. Okay, so we know this is an ellipse because my x squared has a coefficient of 4 and my y squared has a coefficient of 25. These two coefficients are different numbers. If they were the same number, we could have divided the whole equation by that number and just had a plain x squared and a y squared. So we have a number in front of the x squared, a number in front of the y squared, not the same number. That makes it an ellipse. Before we go to graph it, we would like to put this in standard format. Well, the way we put it in standard format is we look at the number on the other side. The number on the other side is 100, but I really want the number to be 1. So I have to divide this by 100. But of course, if I divide this side by 100, I have to divide every term by 100 to maintain my balance. I'm dividing the whole equation through by 100. And I'm going to reduce this. The 4 and the 100 cancel out. The 4 goes into the 100 and gives me 25 in the denominator. So this becomes x squared over 25. Here, the 25 cancels into the 100. That gives me 4, and I get y squared over 4. And here the 100 over the 100 cancels out, and I'm just left with 1. I have gone from the regular format that I was given the equation without any fractions into the standard format. Again, it's very clear when I look at it like this that it has to be an ellipse. And now we can figure out the x-intercepts by taking the a squared, which is the number under the x squared, that's 25. So the a that has to be either plus or minus 5. The x-intercepts are either plus 5 or negative 5. The y-intercepts, well, that we get from the b squared, which is a number under the y squared. The b squared is 4, means the b is plus or minus 2. And therefore, if I would be asked to graph this, I go to 5 on the x and negative 5 on the x, and 2 up and 2 down, and just connect those values, those intercepts, and we get this ellipse. Again, once we have it in standard format, it's easy to see what the graph is going to look like. Okay, let's see if I can give you a problem for you to try. And while you're doing that, I will take attendance. Now, this one is going to require you to think a little bit, because I'm giving you the question backwards. I'm going to tell you what the parabola looks like. And the ellipse looks like. The ellipse has the following intercepts. 4, 0, negative 4, 0, 0, 2, and 0, negative 2. Okay, I want you to write the equation. What's the equation of the ellipse? Okay, while you're doing that, I'm going to be taking attendance. Jesus Antonio. Jackson Avila. Good morning. Tiffany. Tiffany here, Tiffany Vasilo. Kayla. Kayla Brantley. Tashana Caesar. Hi, good morning. Dion Carter.
Good morning, Professor. Good morning.
Good morning. Wensley Charlemagne. Tatiana Collins. Awa Diallo. Good morning. Ashay Douglas. I know she's here. She's having trouble with her internet. So, Eliana. Eliana Estee. Emily Gomez. Anastasia Guerra. Zanabu. Ismail.
Good morning.
Good morning. Jaden. Jaden Jackson. Ashiana. Good morning. Anijah John. Thomas John.
I'm here.
Hi. Paul. Paul LeBrun.
Here.
Hi. Ashley Moorhead. Ashley. Angelica.
Here.
Hi. Good morning.
Hi. Good morning.
Tayon. Tayon. Akim.
I'm here.
Hi. Okay, Tatiana, I got you now. Greg Ricketts. Giovanni Rowe. Hi, Giovanni. And Devin Lee, I saw you here before. You're here. And the J Waddell. All right, I'll give you a couple more minutes on this. It looks good. Okay, I see some people have already got the answer, so let's see if we can do this problem. Okay, I am going to draw a sketch of this. You do not have to do this, but it helps. Sometimes it helps if you look at the sketch. 4, 0 is 4 along the x-axis. Here's 4, 0. Negative 4, 0 is going 4 to the left. Then we have 0, 2, so that's 2 up, and 0, negative 2 is 2 down. And if we connect all 4 of these points, that's going to give us a picture of our ellipse. Well, we know that the standard equation of an ellipse is x squared over a squared plus y squared over b squared equals 1. So really all we have to figure out is the a and the b. Now remember, the a is the x-intercepts. So the a is either plus or minus 4, which means your a squared has to be 16. And your b is your y-intercepts, which are either 2 or negative 2. And of course, that means that the b squared has to be 2 squared, which is 4. So my equation becomes x squared over 16 plus y squared over 4 equals 1. And that would be the equation of this ellipse. So again, you can look at the equation and draw the picture, or you can look at you can take the picture and then from the diagram, you can write the equation, which is what we just did. Okay, thank you. There is one question on the sheet that is a little bit more interesting. So let's see if we can do that example. Or something similar. Okay, here's what we're told. We have an ellipse, and the major axis of the ellipse is 10, and it's along the y-axis. You have to know which way the major axis goes. Is it horizontal or vertical? This is telling us the major axis is vertical because it's along the y-axis. The minor axis is 6. And that's along the x-axis. And we want to write the equation of this ellipse. So let's just, again, draw this. And we know the major axis is along the y-axis, and it's 10, which means from the center of the, which is at the origin, it's going up 5 and down 5. The minor axis is 6, which means, and that's horizontal because it's along the x-axis, and that means it's going 3 to the right and 3 to the left. Because again, the minor axis is 6 is telling you the length of the whole thing from this, so it's from the center, it goes half out to the right and half to the left. So our ellipse is going to look like this. And now we see that our a squared would have to be 9 because the a's are either 3 or -3. The b squared would have to be 25 because it would either have to be +5 or -5 squared. Always remember the a is always goes with the x. The b's always go with the y's, so that our equation comes out to be x squared over 9 plus y squared over 25 equals 1. Again, sometimes on a test or on the final, they may give you a picture of a parabola of an ellipse and ask you, they'll give you several choices, which is the correct equation, or vice versa. They can give you the equation and ask you to pick the correct picture. And again, all you have to do is make sure your equation is in standard format, and then the number under the x squared is the a squared. So that gives you, the a's give you the x-intercepts, the b's give you the y-intercepts. Okay, I'm gonna give you one more to try. Oh, here's one more example to try, and then we'll talk about the hyperbola. Okay, here's a picture. Here's a picture of an ellipse. I want you to pick the correct equation. Pick the correct equation. Which is the correct equation? I'm gonna give you a few minutes to see if you can pick out the correct equation for this ellipse. The ellipse is crossing the y-axis at 4 and -4, and the x-axis at 3 and -3. And which of these is the correct equation for that ellipse? Okay, we have one person has answered it. I'm going to give you one more minute and then we're going to do it together. Okay, let's work at this together. First of all, if you notice, some ellipses look almost like circles because the major axis and the minor axis are almost the same size. In this case, the major axis is 8 units and the minor axis is 6. But they didn't ask us that information. They wanted us to write an equation of this. And we know that our a squared is going to have to be 9, because our a could be either 3 or -3. That's because that's along the x. And the b squared has to be 16, because b can either be +4 or -4. So in standard format, my equation should be x squared over 9 plus y squared over 16 equals 1. Unfortunately, none of these examples are in standard format. So I know that I have to take each of these answers, put them in standard format so I can compare it. I can't compare these to these. This is in regular format, this is in standard format. So let's remember how we put something in standard format. Let's take number A. Number A, we want to put in standard format, we'd have to divide everything by 144 because the standard format is equal to 1. And not 144. So we're dividing everything by 144. So we get 16x squared over 144 plus 9y squared over 144 equaling 144 over 144. And when I divide the 16 into 144, not 16 and 144, you can take out your calculator and do it, gives you 9. And 9 into 144 gives you 16. So the first one in standard form is actually x squared over 9 plus y squared over 16 equals 1. Now, if I compare it, I see that this is actually the right one. I really don't have to go any further because this is the one that matches mine in standard format. Notice if I'm just as a comment, number B in standard format would have been, I would have divided again everything by 144. I'd get 9x squared over 44 plus 16y squared over 144 equaling 144 over 144, which simplified would have given me x squared over 16 plus y squared over 9 equals 1, which would have meant my x-intercepts are plus or minus 4 because my a squared is 16 and my b squared is 9, so my y-intercepts would have been plus or minus 3. And that's not what we have. That's why B is the wrong answer. C, if you took everything and divide everything by 12 to get C into standard form, you get 3x squared over 12 plus 4y squared over 12 equals 12 over 12. And this would have been x squared over 4, which obviously is not that. I don't even have to go any further, and this would have been y squared over 3. So that would be wrong. And this last one has an 16x squared minus a 9. Oh, it should have been y squared, I'm sorry. Minus 9y squared. But when you have the x squared minus the y squared, it's not an ellipse. This is the next type of example, next case of the conic sections, the fourth case, the hyperbola that we're going to be talking about. So looking at this, the answer to this one was A and not B. This is very easy to make this mistake. But remember, it's x squared over a squared plus y squared over b squared. Okay, I'm now going to erase this and I'm going to talk about the hyperbola. This is all you have to know about the ellipse. You have to be able to find put it in standard format. You should be able to draw it. It turns out that the standard, and again, we're only talking about hyperbola, it also has a center. And we're really going to talk the least about a hyperbola. There's much to say about a hyperbola, but we're only interested in the very basics. What does the basic hyperbola look like? And how do we recognize that we have a hyperbola? And are we able to distinguish between one and the other? So the standard equation of a hyperbola is very similar to our equation of our ellipse. It's x squared over a squared minus y squared over b squared equals 1. The basic difference is that the sign between the x squared and the y squared term is minus. It could either be the x squared minus the y squared, or we could have, the other option is to have y squared over b squared minus x squared over a squared equaling 1. So either we have an x squared term minus a y squared, or a y squared minus x squared. In terms of the ellipse where we have a plus, the a and the b have to be different numbers. Here, the a and the b don't have to be different numbers. They could be the same number because the sign in between them is minus. And when you see a minus between your x squared term and your y squared term, you will automatically know that what you have is a hyperbola. Now, what does a hyperbola look like? A hyperbola is a strange looking figure because it has two parts. It has two arms. Sometimes the arms go like this. They almost look like back-to-back parabolas. Sometimes these curves are crossing the x-axis, and sometimes we have something that looks like this, where again we have these two like back-to-back. They're not really parabolas because they're really flatter, but they're basically that type of shape. But sometimes they cross the x-axis, sometimes they cross the y-axis. And it's interesting that when you're going to have the two crossing the x-axis, it's going to be the x squared minus the y squared. Because in this case, if you have the y squared being negative, then your y turns out to be a negative, y squared turns out to be a negative number, which is imaginary. So in this case, where you have x squared over a squared, or y squared minus b squared, the only real intercepts, the only case where you can get real intercepts is where you have the x. Here you get y-intercepts and not x-intercepts. So when we have a hyperbola, we have these two separate pieces to the graph, sometimes sideways, almost looks like when you draw a tree trunk, and sometimes up and down. Again, this is where the x squared term is positive. This is where the y squared term is the positive. Where you have a negative, if you tried to solve it, you would get imaginary numbers, and therefore there are, in this case, no y-intercepts, and in this case, no x-intercepts. So what kind of question could you be asked? Well, first of all, I could give you an equation that looks like this. 4y squared minus 100 x squared. No, I don't want that. I don't want 100. I don't want to get so big. Let's do this 25 x squared equals 100. Suppose I give you this equation. First of all, note, there's an x squared and a y squared term in it. So for sure, if I asked you what it is, you know it's not a parabola because it has both x squareds and y squareds. And the fact that there's a minus between the x squared and the y squared term right away tells you this has to be a hyperbola. When one of your square terms, your x squared, is positive and your y squared is negative or vice versa, that automatically makes it into a hyperbola. Okay, now we know this is hyperbola because of this minus. So what we're going to do is we're going to put it into standard format, just like we did with the ellipse. We're going to divide everything by 100, so it's equal to 1. And reduces, so the 4 over 100 gives me y squared over 25. And the 25 over 100 gives me x squared over 4 equals 1. Okay, now we have this hyperbola equation in standard format. And we can say what the x, the a's, and the b's are. In this case, my a squared is 4. Remember, it's not the 25. The a squared is what's underneath the x squared, which means the a would be plus or minus 2. The b squared is 25, which gives me that my b is plus or minus 5. Now, since the y squared is positive, we're going to have y-intercepts. But since the x squared is negative, there are no x-intercepts. Okay, so the one that's negative will not give us intercepts. The one that's positive will give us intercepts, which means suppose I know that my y-intercepts are going to be 1, 2, 3, 4, 5, and 1, 2, 3, 4, negative 5. And my graph is going to look approximately like this, where it would be crossing the y-axis and it's not crossing the x-intercept axis. There are only going to be 2 intercepts on a hyperbola, either 2 x-intercepts or 2 y, and depending on which is the positive. The one that has a negative in front of it will not give us intercepts. Okay, let's see if I can give you a question to try. I would like you to draw a sketch of this equation. Okay, let's work on this together. First of all, I think we can see that what we're looking at is for sure going to be a hyperbola. It has an x squared term, it has a y squared term, and the sign in between the x squared and the y squared term is negative. It's a minus sign. That means it's hyperbola. And it also means that since it's the x squared term that's positive, that we're going to have x-intercepts. We are not going to have y-intercepts, okay? So where the x squared is positive, we have x-intercepts. Where the y squared is positive, then we have the y-intercepts. But of course, I want to put this in standard format so I can figure out what my A and my B is. So I'm going to divide everything by 48. So the 12 over 48 reduces to x squared over 4. The 3 over 48 reduces to y squared over 16 equals 1. So now we are in standard format. And my a squared is 4, and my b squared is 16. But I only am going to get x-intercepts. The x-intercepts are going to be a plus or minus 2. So my graph will look approximately like this. 2 to the right, 2 to the left, and these two facing away curves, something like that. But we didn't discuss how wide. Sometimes these are narrower, sometimes they're wider. That's beyond the scope of this course. We just at this point should be able to recognize that what we have is a hyperbola and that we're only going to get two intercepts. Sometimes it's going to be x-intercepts, sometimes it's going to be y-intercepts. You have to be very careful as to which one turns out to be the positive one. In this case, the x squared was a positive, then it's a minus y squared. There's a minus in front of that y squared, which means that if I try to solve for y, I would get an imaginary number because I have a negative y squared equals a number. So therefore, there are no y-intercepts, and we get a graph that looks like this. Okay, I just want to now start, then we have two more topics to talk about. One is not in the book, it's trigonometry, and one is in the book. I'm going to go to the topic that's not in the book at this point. I want to leave the last topic, exponential and logarithmic equations and functions, for the last. That's going to be the last topic we talk about. That's chapter 8. So now we're going to a topic that's not in the book. There's not a lot that you have to know about it, but you'd have to, either take notes or listen to make sure you have this information, because otherwise you're going to have to go outside the book. It is not covered in the book. In about a week or so, I will be sending out something that I call a study guide for Math 136. It's I'll email it to you. It's several pages. And what it is all the chapters that we cover in Math 136, the main ideas and some examples. So it's a good review for you. You don't have to go through the whole textbook. And on that, there will also be a review of the trigonometry and all the information that you need to know about trigonometry. So I will be sending that out probably right before Thanksgiving, which is next week. Remember, we have class this Thursday, we have class next Tuesday, but the following Thursday is Thanksgiving and we do not have class. Okay, so as I said, the next topic we're talking about is something called trigonometry. And its name gives you an idea of what we're going to be talking about. The prefix tri has, obviously tri usually like a tricycle or a triplets, all indicate something that has to do with 3. And metry means measurement. And what we're really talking about are triangles, because triangles have 3 sides. And specifically, we're going to be talking about something that's called right triangle trigonometry. So we're going a little bit away from algebra, and we're talking about things that have to do with shapes. And the basic shape of a right triangle looks like this. This little box over here indicates that what we have is something called a right angle. A right angle has 90 degrees, and it's a very popular angle if you look around your house, because most of the things like doors and desks and computers and blackboards have these kind of angles in them. Right angles are 90-degree angles. There's what we call a square corner. And usually if we want to indicate in a triangle that we have this kind of square corner, we just put a little square there so you understand that that is the right angle. Now, when it comes to the triangle, we usually use 3 capital letters to name the triangle. We call this triangle, I'll use a little symbol, A, B, C. The 3 angles are at A, at B, and at C. Usually the C is taken to be the right angle, the 90-degree angle. Angles A and B are what are called acute angles. Acute angles means they're less than 90. So actually, the biggest angle in a right triangle is the right angle. You'll probably remember from other courses that if you take any triangle, not only a right triangle, but any triangle, and you add up all the angles, all the angles in a triangle add up to 180 degrees. No matter what triangle you're going to get, if you add up the angles, they'll always add up to 180. Now the sides can add up to a lot or to a little, because sometimes you can have a big triangle, sometimes you can have a small triangle. But no matter, even if it's a big triangle or a small triangle, when you add up the angles, they always add up to 180. And if you think about it, that must mean that the 2 acute angles in the right triangle add up to together 90 degrees. In other words, if angle A is 30, then angle B would have to be 60 in order for all of them to add up to 180. So these two angles are the A and the B, the acute angles of the triangle add up to 90 together, and the third angle is 90. It's the right angle, and all three of them together make up the three angles of the triangle. We give special names to the different sides. The side of the triangle that's opposite, that means right across from the right angle, is called the hypotenuse of the right triangle. It always is the longest side. If you have a right triangle, the hypotenuse is always going to be the one that's like sort of at an angle there, and it's always going to be the longest side of the right triangle. The other two sides are called legs. There are two legs and one hypotenuse. Those are your three sides of your triangle. Now, it turns out that if we want to look at, I can tell you, look at angle A, I can tell you, look at angle C, and it's clear which angle to look at. But what if I want you to look at a side? Let's say I wanted you to look at the hypotenuse. What letters would I use? I would have to use two letters. I would have to say it's the side A, B, because it's A is at one corner or vertex, and B is at another vertex. So to have to say capital AB, which is very inconvenient. It's very inconvenient to have to use two letters to represent just one item. So what we do is if we use the capital letters for the angles, we're going to use lowercase letters for the sides, and we're going to do it in a very precise way. This leg here happens to be across from angle A, so we call this small a. Remember, using lowercase letters for sides. This side, the side that goes from B to C, is called side A. This side, which is opposite to angle B, will be called small b. It's the one that goes from A to C. It's across from B is side B. And the hypotenuse, which goes from A to B, is across from C, is called small c. It's much easier to say, look at side A, rather than saying, look at side BC. It's easier to use just a single letter. So we use lowercase letters for sides and capital letters for the angles. And before we even get to trigonometry, there's a very important theorem called the Pythagorean theorem that goes like this: a squared plus b squared equals c squared. Again, I'm sure you have seen this before, where it tells you if you have a right triangle and you square, if you multiply each side by itself, if you add the two legs squared, it'll come out to be what the hypotenuse is equal to. So that you might get, this is where I'm going to stop, but I just want to do one example with you. Just erase some of this so it's not so messy. This, remember, was my A, this is my B, and this is my C. If I told you I have a triangle where side A, this is a right triangle, and side A is 7, and side C is 15, and I ask you to find what is side B, in any right triangle, you can always figure out what if you have two sides of the right triangle, you can always figure out the third side by doing this: a squared plus b squared equals c squared. So in this case, we would do 7 squared Well, B, I don't know, that's what I'm looking for, so I'll call it B squared equals C squared, 15 squared. And 7 squared is 49 plus B squared equals, now this is 225, 15 squared. And to find out what B squared is, I'm going to subtract 49 from both sides, which will give me B squared equals 176. And the square root, B would have to be the square root of 176. Actually, in this case, 176 is not a perfect square. You could try it on your calculator. Of course, you want to have your calculator handy. So let's look at our calculator. And let's say they ask us, give the answer to the nearest tenth. I see on my answer, the square root of 176 is 13.266, etc. So to the nearest tenth, my answer would be 13.3. So sometimes it's an irrational number and we don't get the exact answer, and we just use our calculator to find the square root of the numbers. Or sometimes we leave the answer in simplest radical form. If you notice, you can divide this into 16 times 11, which gives you 4 radical 11. So in simplest radical form, your answer would have been 4 radical 11. In decimal form, and again, you have to just read the question, your answer would be 13.3. But all you need to know is 2 sides of the right triangle, and you can use this formula to find the third side. You can use it to find the hypotenuse or to any of the other sides. Okay, we're going to stop right here. And as homework, I don't think I'm assigning any particular homework. I don't think there are questions on delta math on either ellipsis or hyperbolas, so I'm not assigning, though there are definitely questions that I have sent you. You should be starting to review for your final. You should be going through the sample questions, certainly the ones that I put on the weekly, your weekly classes. There are examples with answers worked out, so you should be able to study from that. Again, as I said, I'm going to be sending you a study guide. Very important that you do the examples on the study guide so you know all the different types of examples. Again, we're going to be continuing.
When is the final?
What, excuse me?
Sorry, when is the final?
I don't have the exact date yet of the final, but it's in the middle of December. We only have, this was, as far as I know, this was class number 22. We have 28 classes altogether. So we have, besides us, 3 weeks of class.
So 3 weeks of class and then end of semester?
Yes, and the last class is someplace like the 13th or 14th of December, and then the exact date of the final, I don't know yet.
Is the final going to be like on Delta Math or Blackboard? Or?
Sorry?
The final, what's it going to be on Delta Math or Blackboard?
It's going to be on Blackboard the same way the midterm was, and it's going to be on everything from the beginning of the year. It's not just from the midterm, it's from the beginning of the year. I hope to finish enough time so that we can do some review, but I certainly will be sending you out a practice test. But it's again, a multiple choice test on Blackboard, the same way the midterm was.
A practice test that's like the final, basically.
I'm sorry?
A practice test for the final? Is that what you said?
I didn't hear what you said, I'm sorry.
Did you say practice test for the final?
Yes, I will be sending you, just like I did we did a practice test for the midterm, there's going to be there'll probably be a quiz before that, but there's gonna be a practice test for the final.
How many questions is the final gonna be?
30. The 30 multiple choice questions and you get 2 hours.
All right, thank you.
Any other questions? Okay, so I will see you on Thursday and we'll continue. Have a good week.
Have a good day, Professor.
You too, bye-bye.